All right, welcome. So in the exploration that you did, hopefully you saw two graphs that both looked a lot like this. Some things you should notice about this are that they both start at 0, 0. And that makes sense because when you drop the ball, it shouldn't have been moving at all. And the other thing is that it's increasing in negative velocity as it goes down. So increasing negative velocity, the slopes down. And the other thing is that both of these graphs should have looked very similar. And this was what Galileo figured out, that all objects on Earth accelerate at the same rate. And we know acceleration is the change in velocity. So the slope of both of these graphs is going to be the same. So how much an object change in speed, that's called its acceleration. So both of these objects have the same acceleration. And it turns out, independent of air resistance, the only reason that the feathers might sometimes fall slower is because they are affected by the air a little bit more. But most of the time in this class, we're going to analyze objects where the air resistance is negligible or doesn't affect them. And for those objects on Earth, they're always going to accelerate at the same rate. We're going to call that the acceleration due to gravity, and the value for it is going to be negative 9.8 meters per second squared. And that's going to be one of the numbers that you're going to use most in this class, that negative 9.8 meters per second squared. It's on the very front of your reference tables, and it's the acceleration of any object if it's just in the air falling. All right, let's talk a little bit about what that negative means, especially in front of that 9.8 number. It means that gravity always is going to cause objects to change their speed towards the negative direction. So as an object goes up, the amount that it's going up is going to decrease as it goes up. Once it's going down, the amount that it goes down is going to increase as it goes down. So things are going to slow down on their way up and speed up on their way down. And the amount that they do that is the same. It's 9.8 meters per second squared both times. All right, let's see if we can think about exactly what that means. It means that if I have an object, let's say it starts at the ground, and I throw it up, and at the very beginning, it's moving at 40 meters per second. It's going to go up, and it's that speed, that 40 meters per second, is going to change by a rate of about 9.8 meters per second squared. Now, for the purposes of this thought experiment, we're going to round 9.8 meters per second squared. We're going to say that's very close to 10 meters per second squared. So what that means is after the first second, instead of going up at 40 meters per second, it's still going up, but at 30 meters per second now. After another second, it's still going up again, but now it's decreased by another 10 meters per second. So we're not going up at 30 meters per second anymore. We're going up at 20 meters per second. And after another second, we're no longer even going up at 20 meters per second. We're still going up at around 10 meters per second. And then eventually we're going to get as high as we're going to go. And that 10 meters per second goes down by another 10, and it is not moving at all. It's at 0 meters per second. But its speed is still changing at that same rate of 10 meters per second every second. So another second goes by, it's not going up anymore. It's not at the top anymore. It's going down at a rate of 10 meters per second. And this is going to work the same way the entire way down. After another second, we're going 20 meters per second. We keep going, and we're going 30 meters per second. And right as we get right where we get left off, right when we hit the ground, we are going 40 meters per second in the opposite direction. The last thing that I'd like to go over is a few other graphs as they relate to objects that are falling through the air. So we started off with graphs that looked like this. And remember, those were going down, and they were in that quadrant because they were velocity graphs. But sometimes you might see a speed graph instead of a velocity. Remember, speed is just velocity where direction doesn't matter. So our speed graphs are going to look very similar, but instead of going down, they're going to go up. So if an object is dropped from rest, it's going to speed up as it falls. So its speed graph is going to look just like that. Now, if we threw it up, remember, it's going to slow down on its way up and then speed up on its way down. So if an object's thrown up, it's going to slow down and then speed up. And every once in a while, you'll also see an acceleration graph, and that's just to try to throw you off. But the acceleration of any object as it falls through the earth isn't ever going to change. It doesn't depend on the mass of the object, and it doesn't depend on where it is. So the acceleration is just going to be a flat line that's not going to change. So thank you for watching this video. I hope you enjoyed it.